Hi everyone, today we're looking at Unit 3, Lesson 2, Common Factoring. So this idea of factoring is somewhat of a new idea. In the past you've had to identify common factors, but we haven't had to do much with them other than identify them. Maybe use them to reduce a fraction or use them to clear a fraction. But today we're going to talk about how we actually divide them out of an algebraic expression. So the first thing I want to talk about is that common factoring, which we're going to get to what that is, but this is the opposite of expanding. So in the previous day's notes, we looked at expanding and simplifying. So we distributed a term, whether that was a number or a variable or a number and a variable, inside a set of brackets. We distributed it in by multiplication. The idea of common factoring is that we're going to divide out some factor, okay, the greatest common factor actually. So let's look at what we know about factors and then talk our way through common factoring. So what are the factors of 24? Okay, so when we think about our factors, we can think about them as factor pairs. I know in elementary school sometimes we'll write it as kind of a rainbow from one factor to the next. But if we think about 1 and 24, we know 1 and 24 are factors, 2 and 12, 3 and 4, 3 and 8, and then 4 and 6 is what I was thinking. Okay. Let's think about our factors of 36. So our factors of 36 are factor pairs. This is one way to kind of look at our factors. So we have 1 and 36. We have 2 and 18. We have 3 and 12. 4 and 9, and then 6 times 6, right? Those are all of our factor pairs. So we could look through these list of factor pairs if we wanted to identify what is our greatest common factor, which is what's being asked here. So what is the greatest common factor between those two? And we can see, okay, which number do they have in common that's the biggest between the two? But we could also break them down into a factor tree, and that would kind of pinpoint what is the greatest common factor. So those factor trees we sometimes call our prime factorizations. So let's call this is our factor tree. And we want to break it down into two numbers that we know multiply to 24. Any two numbers. If there's no prime number at the beginning, that's fine, but sometimes there is. So I'm just going to let's use 4 and 6. So 4 times 6. And then can we break down those numbers anymore until we get to basically a prime number? So what multiplies by 4? 2 times 2. Okay, so those are both prime, so we know we're done. We can't factor those any further. Or we can't multiply those down anymore. And then if we think about 6, 2 times 3. All right, so these are what we call our base factors. And there are base factors because they're basically the prime factorization. If we multiplied all those together, we should get back to 24. So 2 times 2 is 4. 4 times 2 is 8, 8 times 3 is 24, right? But that's kind of the prime factorization of it. If we take a look at 36, we'll stick with 6 and 6, and then we'll break those down, and 2 and 3 we know are both prime factors, so we'll use those. 2 times 3, 2 times 3. So if we look at what they have in common, right, there's a 2 in our base factor here and a 2 here. I have another 2 and another 2. And then I also have a 3 and a 3. Okay, you can see at 24 I have another 2, but I don't have that over my 36. So if I'm looking what's common, then it would be those three together. So if we think about those three numbers, 2 times 2 times 3, this is going to equal 12. Okay, and we can also look up in our factor pairs, if we compared all these numbers, we would see 12 is the biggest in this list that is also in this list. So no matter where we pull it from, it's 12, but this way you can kind of have two different strategies in terms of how you like to find your greatest common factor. So some like to list it, and some prefer to do those prime factorization trees. But let's take a look at how do we find the factors of a term. So a term has a number and some variables to it. So what are the factors of 8a squared, b cubed? And then what are the factors of 12a cubed b, and let's remember this is b to the power of 1. So same idea, we want to kind of list our factors and then identify what's common to them. So if we look at, let's just start with our numbers. If we look at a, I'm going to start with that prime factorization tree. We have 2 and we have 4. And then from there we have 2 times 2. Okay, if we do the same thing with 12, we could use 3 and 4. We could use 6 and 2. Let's use 3 and 4. And then we have 2 times 2. Okay, so what's common about these? Their base is 2 times 2 here and 2 times 2 here, right? So our common factor is going to be 4. Okay, so we know 4 is our GCF in terms of numbers. How are we going to identify this for our letter part? Well, let's think about our a. So if I think about a squared, what are the factors of a squared? We have a times a. If I think about what are the factors of a to the power of 3, I have a times a times a. So again, what's common about those? I have a and a here. I have a and a here. Okay, so I have those 2 a's. Okay, and then if we finally look at the our b's, just want to grab another color. Okay, if we look at our b's and the factors of our b's, we have b times b times b. Over here, we just have b. So how many b's do they have in common? Well, there's only one b that's in common to them. So if we had to think about what's the greatest common factor of those 2 terms, we could say is 4, and then we had a times a, which is a squared, and then b to the power of 1. I just want to point out, if we look at our a's, right, we have a squared, and if we look at our b's, we have b to the power of 1. So we're essentially taking, we're essentially taking our greatest common factor of our number and all of our variables, and that's going to represent our greatest common factor. So 4a squared b. Okay, when you're thinking about what's the greatest common factor of a variable part, there's kind of a clue. Okay, so the GCF of a variable is always the variable with the lowest exponent. So if we look at, for example, in that previous example, we had a squared and we had a to the power of 3, right? A squared is an exponent that's lower. That was our GCF. If we look at between our b's, we had b to the power of 3 and b to the power of 1, right? b to the power of 1 is a lower exponent. That was our greatest common factor. So always whichever exponent is lower, that's your greatest common factor. Okay, so let's think about if we were to take this greatest common factor out of a certain expression. So let's think of as an expression. So if I were to add these 2 terms together, for example. So if we had 8a squared b to the power of 3 plus 12a cubed b to the power of 1, right? This idea of taking out a greatest common factor, we're going to divide it out. Because remember, when we're common factoring, we're basically pulling it out of the equation. So what that means is we're going to pull that common factor out front. So I'm going to write that common factor 4a squared b to the power of 1, just so we remember it's power of 1. And then what's going to go inside my brackets is I'm going to show the division of pulling all of that out. So I'm going to take 8a squared b3, and I'm going to divide that by my greatest common factor. So that's going to represent that I'm trying to pull 4a squared b1 out of that term. Plus, I'm going to do the same thing to this term. So now we have to remember those power laws that we went over in a previous day's notes. So now we're going to write the result of all of that division. Okay, so I'm just going to make a note here. In this bracket, I'm going to write the result of the division. So 8 divided by 4 is 2, and then our a's will cancel out, well, or we can think about our subtraction. So 2 minus 2 is 0, and then we'll have b3 divided by b to the power of 1, so we'll subtract those to get b to the power of 2. And then we'll do the same thing with our other term with 12 divided by 4. So 12 divided by 4 is 3, and then our a's, again, we'll subtract our exponents, so we'll get 1. And we have b to the power of 1 over b to the power of 1, so that'll be b to the power of 0. Okay, remembering what we know with our exponent laws, anything to the power of 0 is just 1. So if I have a to the power of 0, that's just 1. So 2 times 1 is 2. And then the same is true over here. Okay, if we have b to the power of 0, that's just 1. But 1 times 3 would just be 3. We don't need to write it. Okay, so these are the leftovers from factoring for a squared b, right? We pulled out that 4a squared and b. Okay, if you ever wanted to check your work, okay, you could always check it by expanding. So I'm just going to try to squeeze that over here. So let's say check by expanding. Okay, so if we wanted to expand it back in, I have 4a squared b to the power of 1, and then inside my brackets we had 2b squared plus 3a. If I were to expand that, okay, so multiply everything outside, inside, I have 4 times 2 is 8. I'm going to have a squared. And then b to the power of 1 times b to the power of 2 is going to be b to the power of 3. And then I'll multiply by my 3a as well. So 4 times 3 is 12. A squared times a is a to the power of 3. And then I have that b to the power of 1. So you can see that when we expand it, we distribute it back in, we get back to where we started. Because factoring and expanding are just opposite operations to each other, and we're going to continue working with those. So what have we kind of done here? We'll look at this note. It says when common factoring, you're going to find the greatest common factor. Okay, so we need to identify the greatest common factor of both the coefficient, so the number, and the variable. And then you're going to divide each term by that greatest common factor. So we're going to get some practice with this on the next page. Okay, so common factor the following. So we have to first identify what is my greatest common factor. So my GCF is, if I look at 8 and 6, my greatest common factor, 8 and 16 rather, my greatest common factor there is going to be 8. And then if we take a look at the variable, we have m squared and we have m to the power of 1. So my greatest common factor there is going to be just m to the power of 1. Okay, so I'm going to pull that greatest common factor out front, and then inside my brackets, I'm going to show the division of pulling that out. So 8m plus 16m divided by 8m. Okay, so then we will write the result of that division. So 8m squared divided by 8m is just going to be m to the power of 1, plus 16m divided by 8m is just going to be 2. Okay, let's take a look at another one. So our GCF here, our GCF of our numbers, so the GCF of 10 and 5 is going to be 5. And then if we look at our x's, x with the lowest exponent is a 1. So that's what's going to be common. If we take a look at our y's, we only have a y in this term. So it's not common between the two terms. So we can't factor out that. And we only have a z in this term. So because it's not common in both terms, again, we can't factor it out. So we're going to show pulling that 5x out front, and then inside our brackets is going to be the division of all that. So 10xy divided by 5x minus 5x squared z all over 5x. So we still have our 5x out front, and inside our brackets, we're going to have 10 divided by 5 is 2. and those x's will cancel out. We'll just be left with y. Okay, and then we have 5 divided by 5 is 1. And then we'll have x squared divided by x will just be x. We'll subtract those exponents, and we have z. Okay, we can write that without the 1 inside of our brackets as well, right? We could write just the variable, so we'll have 2y minus x z. Okay. As you get more comfortable with this, we're going to try to not have to write the division part. We're going to try to do some of that in our head. So let's look at this next one. If we have 4a plus 18b, okay, our GCF is going to be 2. So if I want to pull a 2 out front, I'm going to think about what does that look like when I divide 4a by 2. Okay, well 4a divided by 2 is going to be just 2a. So I'm going to try thinking through some of that division instead of always having to write that step. 18b divided by 2 is 9b. And if it's helpful for you to keep writing that step until you get used to it, that's perfectly fine as well. All right, let's take a look at that next one. So our next one is 28x squared minus 7 plus 21x. Okay, so we have, on our numbers, we have 3 numbers now. We have 28, 7, and 21. Hopefully we can take some time to think about what would the greatest common factor be here. And our GCF is going to be 7. I can't pull out any variables because I only have an x squared here and an x. I don't have any x's on my 7s, so there's nothing I can pull out that's common to all 3 terms. So if I pull out a 7, I have to think about what that division looks like, okay? So if I pull out a 7 from 28x squared, that means I'm going to divide it out. I'm going to be left with 4x squared. And then if I have a negative 7 divided by 7, usually when we see this, we think, oh, they just cancel each other out, but we have to remember what it means, okay? 7 divided by 7 is 1. So I have a negative 1 here. And then 21x divided by 7 is 3x. And I just like to make note of this because students want to often just cancel that out as if it's a 0, but you need the 1 as a placeholder for your second term. Because if we were going to distribute that 7 back in, right, if I was going to distribute this back in here and there was nothing there, then that 7 wouldn't end up back there if I did so. So we just have to make sure that we have that 1 there to represent 7 divided by 7 is 1, and it's a placeholder if we were to expand back in. Okay, let's try one more together, and then I'm going to get you guys to try F. So if we take a look at E, again, we're going to identify that greatest common factor. So my GCF is, okay, if I look at my numbers, I have 12, 8, and 16. So what's the greatest common factor between those 3 numbers? It is going to be 4. And then we have to take a look at our variables. So I have p to the power of 4, p to the power of 3, and p to the power of 2. Well, the most p's they're going to have in common is p squared. So that's going to be my GCF. So I'm going to pull that GCF out front, and then I'm going to divide each term by 4p squared. So 12p to the power of 4 divided by 4p squared, we're going to have 3p, and then we have to remember that we're going to subtract those 2 exponents. So 4 minus 2 is going to be 2. Okay, 8p to the power of 3 divided by 4p squared, we're going to be 2p. And again, if we subtract those exponents, exponent of 1, and then finally 16p squared divided by 4p squared, we're going to have 4. And then p squared divided by p squared is going to be p to the power of 0. So we have to remember p to the power of 0 is just 1. So that would be 4 times 1, which is just 4. Oh, and we also don't need to write that 1 on as an exponent, right? We know that it's always raised to a power of 1. Okay, I'd like you to pause the video and see if you can try F on your own, and then we're going to come back and we'll try G together. All right, so that's the answer you should have gotten when you factored out the common factor for F. Our common factor would have been MN, so there would have been no common factor for our numbers because this term here just had a coefficient of 1 on it. Okay, and then I just showed going from here to here, we don't need to write the 1 in front of our M. So I just wrote that again with just the minus M in the middle. Okay, hopefully we got that. This last one we're going to look at when we look at common factoring. So you need to remember that a term is always connected by multiplication. So sometimes what's common in an expression is not necessarily another number. It could be a bracketed piece or what we call a binomial. So if we look at this next example, this would be considered one term because it's all connected through multiplication. Like the 3x is being multiplied by my bracket, and this would be considered another term within my expression because it's connected by multiplication. Okay, so these are two terms. So there are two terms in this expression. Okay, what's common about those two terms? Hopefully we can see that they both have this 2x plus 5. So there's a common bracket in both terms. So that's what we're actually going to factor out. So if I was to think about pulling a 2x plus 5 out front, we would have a 2x plus 5. Okay, well, if I pull a 2x plus 5 out of this term, we have to think about what am I left with. Okay, well, I'm going to be left with 3x, right? That's going to go inside my brackets. And if I pull a 2x plus 5 out of this term, what am I left with? I'm left with just a minus 7. Okay, so again, this is the leftovers from factoring out the bracket. We'll continue to practice common factoring, and we'll also learn some other types of factoring in this unit, but that's it for your note for today.